Hello, my name is Lakshmi. I am a PhD student in Human Computer Interaction Lab at UC Merced. I am going to present the work exploring the acceptability of speech and silent speech as active input methods in private and public places. Silent speech input interprets users' lip and tongue motions into text. It is a promising alternative to speech input in contexts where acoustic signal is unavailable or unreliable. Though the method shows promises, very little is known about people's perception regarding using it to interact with mobile devices in private and public settings. In our exploration, we study social acceptance of speech and silent speech input, considering factors such as users' and viewers' perspectives towards using the methods in different locations and among different audiences. We first conducted an online survey on Amazon Mechanical Turk with 71 participants to explore the social acceptance of both input methods. Participants were asked to watch a set of video clips where users were using either speech or silent speech to interact with mobile devices. We then asked them to provide their feedback on social acceptance of these methods considering different locations and audiences. The social acceptability for both methods from users and viewers' perspectives were significantly different across locations on mobile devices, as users preferred using silent speech as it is less noticeable. But we did not find any significant difference between two methods across audiences. In subjective feedback, participants expressed their interest in using silent speech input as it is more subtle and provide high degree of privacy and security than the other method. The findings indicated that there are accuracy and interaction factors that could influence their attitude towards using the method. For instance, silent speech recognition accuracy could be one of the key factors in adopting the method as it could be highly error-prone. We conducted a Wizard of Oz study with 12 participants to explore users' attitude towards recognition error in speech and silent speech, where we injected 0%, 5%, 10%, 15%, and 20% misrecognition errors. During the study, participants entered short English phrases using speech and silent speech at varying injected error rates. We then collected user response to the error rate for two input methods in a questionnaire that asked them to rate their willingness to use the methods. Results revealed that 0% and 5% error rate yielded the highest and 20% error rate yielded the lowest willingness to use ratings for both methods. Interestingly, for 10% and 15% error rates, the willingness to use ratings for speech dropped at a higher rate than silent speech. This suggests that users were willing to tolerate more errors in silent speech to uphold privacy and security. Silent speech input recognition on mobile devices depends primarily on capturing users' tongue and lip movements via the front camera. Thus, providing appropriate real-time feedback on input recognition is critical for the acceptance of the method. We conducted a user study to compare two different types of feedback mechanism for silent speech input. The first is abstract, that uses a red blinking icon, and the second is detailed, that displays real-time video of users. We conducted the study with 12 participants. During the study, participants entered short English phrases using silent speech with both feedback methods, and then responded to a questionnaire that asked them to rate various aspects of both methods. Results showed that users find both feedback methods effective, but the video feedback significantly more informative than abstract feedback. Yet, they were slightly leaning towards using the abstract feedback since they found it to be least intrusive and significantly more private and secure than the video feedback. Our findings confirm that silent speech input is more socially acceptable as it is subtle, more secure, and less attention-seeking than speech input. Furthermore, users are willing to accept more recognition errors with silent speech input than speech input. Our final study showed that users find a commonly used video feedback and an abstract feedback effective, but the latter to be significantly more private and secure than the video feedback. Thank you. I am happy to take any questions you may have about the work. Also, feel free to ask us questions or comment on our work via our social media channels.